All right, a little review for your quiz type of do section today. Sohcahtoa, back to the beginning. Sohcahtoa stands for sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So you're taking two tests on Friday. The first one is just going to deal with this. They're just going to be asking you what is sine, cosine, and tangent of a given triangle, and your answer is going to be a fraction. So how do you write the fraction answer for these 6 problems that I've put here? You use Sohcahtoa. So sine of A, sine is always opposite over hypotenuse. What is the opposite side of A? It's 5. What is the hypotenuse of this triangle? It's 13. So opposite over hypotenuse of A is 5 over 13. And that's it. That's how easy trigonometry starts, and then it gets more complicated from there. But for the first 5 questions, it's going to be pretty much this simple. Cosine of A is adjacent over hypotenuse. Well, we already figured out the hypotenuse was 13, so it's going to be over 13. And which one is adjacent? Well, it can't be 13 because that's the hypotenuse. Can't be 5 because we just figured that was the opposite. It's got to be 12. 12 is the one that is right next to A. It's one of the sides that make up angle A that is not the hypotenuse. It's 12 over 13. Oops, I wrote a 13 over 13. That's better. And then the tangent of A does not use the hypotenuse. Tangent is opposite over adjacent. It's the only one that doesn't use a hypotenuse. We already figured out what the opposite and adjacent sides were. Opposite was 5, adjacent was 12, so it's 5 over 12. Opposite of A is 5, adjacent is 12, 5 over 12. All right, now there's a pattern to figure out the other angle in the triangle B. It's basically the opposite of these. Sine of B would be the same as cosine. Cosine of B would be the same as sine of A, and the tangent of B would be the reciprocal. But I'll go through them the way I did the first ones. Sine of B is opposite over hypotenuse. The hypotenuse is 13. That doesn't change regardless of what angle you're looking at. So cosine and sine are still both going to be over 13. It's the numerators that are going to change because now the opposite of B is not 5, it's 12. Opposite of A was 5, opposite of B is 12. So it's 12 over 13, and then cosine is 5 over 13, because right next to B is 13 and 5. Those are the two sides that make up B. But 13 is the hypotenuse, so it has to be 5 as the adjacent side. So this is what I was talking about, the pattern. 12 over 13 sine of B is the same as cosine of A. 5 over 13 cosine of B is the same as sine of A. And then tangent of B, the opposite. We already figured the opposite was 12. The adjacent was 5, so it's 12 over 5. And that is the reciprocal of the tangent of A. 5 over 12, 12 over 5. All right, there's your Sohcahtoa review. That's basically the whole first test. They will try and give you some trickier problems, but it's still that same concept like this. If they were to ask you what is the sine of A in this triangle? Well, there's actually 2 triangles there, and they're similar triangles because they share angle A, and they both have a right angle, so angle, angle. These are similar triangles. Angle A is in both triangles. So when they say sine of A, are they talking about 5 over 13, or are they talking about 15 over whatever this hypotenuse is? Well, what is that hypotenuse? Maybe it's better to redraw these as a little triangle with 5 and 13, and a big triangle with 15 and what? What's the hypotenuse of the big triangle? It's both of these measures combined, which is 39. So sine of A, what's the right answer? This is A in both of them. Is it 5 over 13, or is it 15 over 39? Well, this one reduces. 3 goes into both those numbers evenly. How many times does 3 go into those? 5 and 13 times. So, oh, it doesn't matter. They're both the exact same thing. And that's what happens with similar triangles. If you have similar triangles, the sine, the cosine, and the tangent does not change. So it doesn't matter which triangle you pick. All right, and then the second set of 5 questions has to do with solving for missing sides and missing angles. So here's an example of solving for a missing side, and this will be an example of solving for a missing angle. That's actually the number 2, not a z. I just noticed how it could be viewed as either. There's a nice fancy 2. All right, so how would you solve for x and y, the 2 sides in this problem? Well, let's start with x. X is the hypotenuse, and we have to use the number 2 because we can't use x and y. We can't say cosine of 30 is equal to y over x. Now that is true. The cosine of 30 is the adjacent over the hypotenuse, but we're not going to be able to solve for one of these variables in this problem because we have 2 variables in the same problem. That's always a big no-no. You can't solve for 2 variables in one problem. Got to have it down to just one variable. So we can't use cosine, we got to use sine or tangent. So if we're going to solve for x, x is the hypotenuse, we have to use sine. All right, we have to use the 2, that's the opposite side, and then x would be the hypotenuse. Opposite over hypotenuse, that'd be sine. So sine of 30 is equal to 2 over x. All right, good. Now we have a problem with only one variable in it, but it's in the denominator, which is annoying. We have to get it to the numerator, so it has to go to the other side, and then the sine 30 has to divide back over here. So these 2 switch. Remember, if x is in the denominator, you're going to have to divide in this problem. You're going to have to switch your sine 30 and your x so that it looks like this. So it's 2 divided by sine 30. Denominator, divide. Sine of 30 is 0.5, and 2 divided by 0.5 is 4, so x would be 4 in that problem. All right, what if we're going to solve for y now? Now I guess you could use cosine because we know that's 4, but let's say we decided to do y first. We didn't know that was 4 yet. You'd have to use tangent, 2 over y. Well, that gives y in the denominator. Let's use 4 because I want to have x in the numerator for an example. So now that we know this is 4, x is equal to 4, now we can use the cosine to solve for y because the cosine of 30 is equal to y over 4. So now we have a good equation here with only one variable in it. We have to solve for it by getting it by itself, so you multiply the denominator to the other side and you get 4 times cosine 30 is equal to y. And if you use your calculator, you're going to get a decimal that's equivalent to 8 times square root of 3. Just going to have to trust me or check me on that one. But I'm pretty much absolutely positive that's right. All right, so 8 square root of 3. How did I get that? Because this is a 30, 60, 90 triangle, which is a 1, 2 square root of 3, but it's twice as big as your normal one. Instead of 1 and 2, it's 2 and 4. So instead of square root of 3, this must be square root of 2 times square root of 3. So I know y is 2 times square root of 3. I made this triangle on purpose so I already knew what the answer was, so I didn't have to use my calculator. So I know the answer is 2 times square root of 3. So why did I say it was 8? I don't know. Oh, because I multiplied it by 4, right? All right. So there. Now you can check me and it'll be right. 2 square root of 3 would be the answer on that one. Square root of 3 is like 1.7 almost, so it's going to be like 3.4, right around in that region if you use your calculator. Okay, solving for a missing angle now is very similar to solving for a missing side. You still have to decide if you're using sine, cosine, or tangent, but then now your variable is in the angle position instead of side position. So what are we going to use here to solve for x? We have to use these 2 numbers. So what are those 2 sides in relation to angle x? Well, one of them is the hypotenuse, that's the 4, The other one is opposite side from x. So opposite in the hypotenuse, that means sine. So sine of x is equal to 2 over 4. 2 over 4. How do you solve for x? You have to get x by itself. That means you have to split sine and x up. You have to break up their best friendship and make sine all bitter and negative about life. -1. The inverse of sine. And the inverse sine of 2 over 4, which is 1/2, the inverse sine of 1/2 is 30. So x is equal to 30 degrees in that one. So that's how you solve for a missing sign. You just use Sohcahtoa, and then you solve for the variable. If your variable is in the denominator, it's a division problem. If your variable is in the numerator, it's a multiplication problem. And then to solve for missing angle, you use the inverse of the sign. It's all still using Sohcahtoa. You just have to decide which one to use, sine, cosine, tangent, and then you solve for the missing variable, and that's it. 10 questions. You guys are going to ace it.